Have you ever looked up at the night sky and wondered if we are alone in the universe? Who hasn't? It's an innate curiosity, a question that has echoed through the ages, reverberating across every culture, every civilization. Are we alone? This question is not just a product of our modern understanding, but a fundamental part of our human nature. It's the driving force that propels us to explore, to question, to seek answers in the vastness of the cosmos that surrounds us. The universe is an enormous place, a cosmic tapestry woven together with countless galaxies, each home to billions of stars. And around these stars perhaps orbit planets like our own. This idea is not mere speculation. It's based on the scientific observation of our universe, a universe that is estimated to be around 13.8 billion years old and spans a mind-boggling 93 billion light-years in diameter. But within this vastness, where does that leave us? Tiny specks of life on a small blue planet orbiting an average star in the outskirts of the Milky Way galaxy. Are we a cosmic anomaly, a unique occurrence in the vast sea of stars? Or are we perhaps not as alone as we might think? These are questions that have perplexed and intrigued us for centuries. The search for alien life, for other beings in the cosmos, is a search that speaks to our deepest desires, our most profound questions about our existence. It's a search that transcends borders, cultures, and generations. As we begin to probe the mysteries of the universe, we're not just searching for extraterrestrial life. We're also seeking to understand our place in the cosmos, to unravel the threads of our own existence, and to find answers to the questions that have haunted us since we first looked up at the stars. As we embark on this journey through time and space, we'll delve into humanity's relentless pursuit to answer this age-old question. Are we alone? The idea of life beyond Earth is not new. Since time immemorial, humans have gazed at the stars and pondered about the existence of extraterrestrial life. This curiosity has been a constant companion, guiding us through the ages. In the cradle of civilization, the ancient Sumerians spun tales of gods descending from the heavens. They believed these deities hailed from the heavenly ocean, an infinite expanse of cosmos teeming with life. Meanwhile, in the land of the pharaohs, the ancient Egyptians revered celestial bodies like Sirius, believing them to be the abode of their gods. Fast forward to the classical era, where philosophers and scholars like Epicurus postulated the existence of infinite worlds teeming with life. His contemporary, the Roman poet Lucretius, echoed these sentiments in his seminal work, On the Nature of Things, suggesting that life was not unique to Earth. As we enter the age of Renaissance and Enlightenment, the idea of extraterrestrial life gained more scientific grounding. The great polymath Johannes Kepler, in a fit of imaginative brilliance, speculated about inhabitants on the moon in his work Somnium. Around the same time, the philosopher Giordano Bruno controversially proposed that the universe was infinite, filled with a multitude of worlds, each potentially harboring life. In the 19th century, the renowned astronomer William Herschel, who discovered Uranus, postulated that every planet in our solar system was inhabited. His speculations were based on analogies with Earth and the assumption that the Creator wouldn't waste space. Indeed, from ancient civilizations to modern times, the idea of life beyond our blue planet has captivated the human imagination. These speculations, these dreams of alien worlds and civilizations have shaped our understanding of the universe and our place within it. They have sparked a curiosity that has propelled humanity's quest for knowledge, pushing us to explore and understand the cosmos. These speculations laid the foundation for a quest that would lead us to the stars. The birth of modern astronomy opened new doors in our search for extraterrestrial life. With the advent of the telescope, our view of the cosmos was forever transformed. This humble instrument, merely a tube with lenses, brought the heavens closer and made the stars our neighbors. Around the turn of the 17th century, Galileo Galilei, an Italian polymath, pointed his telescope skyward. His observations led to conclusions that shook the foundations of the world. He saw mountains on the moon, spots on the sun, and moons around Jupiter. The Earth, he proposed, was not the center of the universe, but merely one planet among many orbiting the sun. Galileo's revolutionary ideas built upon the work of an earlier pioneer, Nicholas Copernicus. A Polish astronomer from the Renaissance period, Copernicus proposed the heliocentric model of the universe, where the sun, not the Earth, was at the center. This model suggested a universe of vast scale and possibility, a universe where other worlds might exist, and with them, perhaps, other forms of life. The telescope and the heliocentric model gave us a new perspective, a viewpoint from which to consider our place in the cosmos. We were no longer the center of everything. We were part of a vast, intricate dance of celestial bodies, spinning around the sun, which was itself just one star among countless others in the Milky Way. This realization sparked a new curiosity. If Earth could support life, why not other planets? Could there be beings looking back at us from the surface of Mars or from the moons of Jupiter? The seeds of the search for extraterrestrial life were sown. This shift in understanding marked the dawn of modern astronomy. It was a time of great discovery and even greater questions that would drive us to probe deeper into the cosmos, to listen for signals from distant stars and to send our messages into the void. As our understanding of the universe expanded, so did our hopes of finding alien life. In the mid-20th century, the search for extraterrestrial intelligence, or SETI, took center stage. The cosmos suddenly seemed more accessible and full of potential life than ever before. Born from the curiosity of humankind and the advancements in technology, the SETI initiative embarked on an audacious journey to answer the age-old question: are we alone in the universe? SETI's mission was ambitious yet straightforward. The initiative aimed to detect radio signals from civilizations beyond our solar system. If there was intelligent life out there using technology similar to ours, then perhaps, just perhaps, they might be broadcasting their presence to the cosmos. Central to SETI's efforts was the advent of radio astronomy. With radio telescopes, scientists could listen to the cosmos in a way never before possible. They were no longer limited to visible light from celestial bodies. Instead, they could now detect radio waves, the invisible light, if you will, that pervades the universe. This opened up a whole new window onto the cosmos, potentially allowing us to eavesdrop on alien broadcasts. And then there's the Drake equation. Formulated by astronomer Frank Drake in the early 1960s, this equation doesn't give us a definitive answer, but it provides us with a framework for estimating the number of advanced civilizations that might exist in our galaxy. It takes into account factors like the rate of star formation, the fraction of those stars with planetary systems, the number of planets that could potentially support life, and several other variables. The Drake equation, while steeped in uncertainty, serves as a guiding light for SETI's search for extraterrestrial intelligence. Through the decades, SETI's quest has been marked by moments of excitement and long stretches of silence. Yet, the search continues, unabated, fueled by our innate curiosity and the tantalizing possibility that we may one day find evidence of intelligent life beyond our little blue planet. SETI's efforts have been a beacon of hope in our quest to find intelligent life beyond Earth. Humanity reached out to the cosmos with the launch of the Voyager spacecrafts in 1977. This was our first attempt to make contact with any potential extraterrestrial life in the universe, and we did it in a truly unique way. The Voyager missions were more than just scientific endeavors. They were humanity's message in a bottle, cast into the cosmic sea. On board each of the two spacecrafts, Voyager 1 and Voyager 2, was a golden record. This was no ordinary record. It was a time capsule, a message from Earth to the cosmos. The golden record was a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. It was our way of saying, hello, is there anybody out there? It was a snapshot of our world, a way to showcase our existence, our achievements, and our hopes. The record included a variety of natural sounds like those of surf, wind, thunder, birds, whales, and other animals. It also contained musical selections from different cultures and eras, spoken greetings in 55 languages, and printed messages from then-President Jimmy Carter and UN Secretary General Kurt Waldheim. To prepare for the possibility that extraterrestrial life might find the record, instructions explaining how to play it were engraved on the disc's cover in a language universal to all, the language of science and mathematics. These Voyager missions, launched more than 4 decades ago, have now traveled beyond our solar system, carrying with them our messages of peace, curiosity, and the thirst for knowledge. They are our humble ambassadors in the cosmos, silent and patient, waiting for a response that might never come. But the journey is not over. The Voyagers are still out there, still traveling, still carrying our message. They are our testament to the universe, a testament of a species that dared to reach out into the unknown, to say, we are here, we exist. The Voyager missions, still traversing the vast cosmos, symbolize our longing to connect with alien life. Our search for alien life has led us to the discovery of thousands of exoplanets. Exoplanets, or extrasolar planets, are celestial bodies that orbit stars beyond our own sun. They are like the planets in our solar system, but they belong to other star systems. The first confirmed detection of an exoplanet came in the early 90s, and since then, our technology and understanding have evolved, leading to the discovery of thousands more. Some of these exoplanets are similar to Earth in size and temperature, raising the tantalizing possibility of life beyond our home planet. Now, let's talk about an intriguing concept, the habitable zone, or the Goldilocks zone. You remember the story of Goldilocks, right? She wanted her porridge not too hot, not too cold, but just right. Similarly, the habitable zone refers to the orbital region around a star where conditions might be just right, not too hot, not too cold, for liquid water to exist on the surface of a planet. And where there's water, there's a chance for life. These zones are not a one-size-fits-all, though. They depend on the size and temperature of the star. A bigger, hotter star has a more distant, habitable zone, while a smaller, cooler star, like a red dwarf, has a habitable zone that's closer. The discovery of exoplanets and the understanding of habitable zones have significantly boosted our search for life. We've gone from wondering if other planets exist beyond our solar system to knowing they do, and that some of them might even have the right conditions for life. It's as if we've opened a new cosmic door, one that could lead us to the discovery of alien life. And so, as we gaze into the cosmos, we find ourselves drawn to these distant worlds, these exoplanets in their habitable zones. Not because they are like our Earth, but because they hold the potential to harbor life. These distant worlds hold the promise of answering our existential question. While the search for intelligent life continues, scientists are also looking for simpler forms of life. Welcome to the fascinating realm of astrobiology, the study of life in the universe. This science not only searches for extraterrestrial life, but also seeks to understand the origins and evolution of life on Earth. One of the most promising locations in our search for microbial life is the red planet, Mars. Mars has been the target of numerous exploratory missions, with rovers like Spirit, Opportunity, Curiosity, and most recently, Perseverance, traversing its dusty terrain. These robotic explorers are equipped with a variety of tools to investigate the Martian surface and atmosphere. Scientists have long suspected that Mars once held more Earth-like conditions, capable of supporting life as we know it. The Mars rovers have provided substantial evidence to support this hypothesis. They've discovered signs of ancient water, the building blocks of life, and even seasonal methane emissions, a possible sign of microbial life. But Mars isn't the only celestial body under the astrobiological microscope. The icy moons of Jupiter and Saturn, such as Europa and Enceladus, are also intriguing candidates. These moons harbor vast oceans beneath their frozen surfaces, which could potentially sustain life. Astrobiology is a multidisciplinary field, combining aspects of biology, astronomy, and geology, among others. It's a testament to our insatiable curiosity and our quest to answer one of the most profound questions: are we alone in the universe? The search for microbial life may not yield advanced civilizations or little green men, but it's a crucial part of our cosmic journey. The discovery of even the simplest microbe on another planet or moon would revolutionize our understanding of life. It would confirm that life can exist beyond Earth and open up countless new avenues for exploration. The discovery of microbial life may be a small step, but it would be a giant leap in our quest for alien life. The search for alien life is far from over. As we gaze into the vast expanse of the cosmos, our curiosity grows stronger and our tools become more sophisticated. The future of the search for extraterrestrial life looks bright, with a host of upcoming missions and technological advancements on the horizon. Consider initiatives like Breakthrough, Listen. This ambitious project, backed by some of the most brilliant minds of our time, aims to survey 1 million of the closest stars to Earth, the center of our Milky Way galaxy, and the 100 nearest galaxies. With state-of-the-art equipment, Breakthrough Listen is set to detect signals that may be indicative of advanced extraterrestrial civilizations. Meanwhile, the highly anticipated James Webb Space Telescope is gearing up to revolutionize our understanding of the universe. With capabilities far exceeding the Hubble Space Telescope, the James Webb is designed to peer back into the early universe, study the formation of stars and galaxies, and investigate the atmospheres of exoplanets. It may just provide us with the evidence we need to confirm the existence of life beyond Earth. There's also a growing focus on astrobiology, the study of life's origin, evolution, and distribution in the universe. Scientists are looking into extremophiles, organisms that can survive in extreme environments on Earth, to understand how life might thrive in harsh alien worlds. In addition, there are plans for new missions to Mars, Europa, and Enceladus, moons of Jupiter and Saturn, respectively. These missions are designed to search for signs of current or past life, further expanding our understanding of where life could exist. The future of the search for extraterrestrial life is a thrilling blend of potential discoveries, technological leaps, and unending curiosity. Our journey may be long and fraught with challenges, but every step brings us closer to answering the question that has captivated us for centuries. So, are we alone in the universe? As we've journeyed through the cosmos in our discussion, we've probed the depths of this profound question. We've traced our steps from the early speculations, where the universe was considered a celestial playground teeming with divine beings, to the dawn of modern astronomy, where we began to understand the vastness of space and our place within it. We explored the SETI initiative, a beacon of hope, tirelessly scanning the cosmos for signs of intelligent life. We marveled at the Golden Record and the Voyager missions, mankind's message in a bottle, thrown into the cosmic sea, carrying our hopes and dreams into the unknown. Our journey took us to the realm of exoplanets and the concept of the habitable zone. We've learned that conditions suitable for life as we know it are not as rare as once thought. The discovery of these Goldilocks planets has brought a new sense of optimism to our quest. We delved into the fascinating field of astrobiology, where scientists are searching for signs of microbial life on Mars and other celestial bodies within our solar system. This search is not just about finding aliens, but also about understanding the very nature of life itself. As we look to the future, our search continues, fueled by our ceaseless curiosity and the tantalizing possibility that we may not be alone. We stand at the threshold of discovery, armed with new technologies and a deeper understanding of our universe. So, are we alone? The truth is, we simply don't know yet, but every day, we inch closer to an answer. And whether that answer is a resounding yes or an exhilarating no, the journey of discovery is just as important as the destination. Whether we are alone or not, the search for alien life is a testament to our curiosity, our desire to understand the universe, and our quest to find our place within it.